Okay, so as I just said, an inequation is an equation that doesn't have an equal sign. For example, x is less than y, or x is greater than 3, or y is less than or equal to -1. Somehow you have to have a system that you remember that this is less than and this one is greater than. Okay. Some people think of it as alligator mouth, pointing towards the bigger of the two values. This is the open, that's the open end of the mouth. Only that doesn't work, doesn't necessarily tell you which means less than and which means greater than. So I'll leave it for you to work out how you're going to remember which way around a less than sign is and which way around a greater than sign is. For solving these things, all you need to do is consider the inequality, i.e. the less than or greater than sign, to be an equal sign, and only swap the sign over when dividing, or does anyone know the answer? Dividing by what? I'm going to also say or multiplying, right? Or multiplying by minus or by negative. So this is the only sort of new rule, if you like. Okay, so this is the new rule that you'll need to remember. Let me give you an example. X plus 3 is greater than 5. We need to solve for x. So in my head, all I'm going to do is think of the inequality sign as an equal sign and solve it as per usual by going 5 minus 3. Change the positive 3 to a minus. Okay, and then x, I still need that inequality sign. It hasn't changed because I have it divided or times by a negative. So that reads that as long as x is greater than 2, this statement is true. And you can test your answer. If you put 2 in for x, that's just a line, by the way, that's not an equal sign. Sorry, you can't put 2 in for x, can you? Because x has to be greater than 2. It can't be equal to 2, it has to be greater than 2. So let's start with putting 3 in for x. 3 plus 3 is 6. That is greater than 5. So that works. And you can see if I put 4 in, if I put 5 in, if I put 6 in. So the solution is x has to be greater than 2. Let's just do one with a negative in it to let me show you what I mean by changing the sign. Negative 2x, so this is example 2. Example 1. Negative 2x has to be greater or equal to 6. Okay, simple numbers. And in my mind, I'm thinking that the inequality sign is literally an equal sign. Let's move it up. Okay, and this time I'm going to solve this problem, I'm going to have to divide both sides by negative. That's a divided by sign. Divide both sides by negative. Now what that does is it swaps the sign from a greater than to a less than. Solving as per usual would look like this. 6 divided by negative 2 is negative 3. However, my answer isn't an equal sign. That's just what's going on in my head. My answer is an inequality, and instead of copying the original sign, I have to swap it over and make it a less than sign of negative 3. Less than or equal than sign. So just check my answer. If I put negative 3, because remember it's allowed to be negative 3 this time, in for x, minus 2 times minus 3 is minus 6. Sorry, is positive 6, isn't it? And that would be equal to or greater than positive 6. So that minus 3 will work. If I choose, remember I have to go less than minus 3. So if I choose minus 4, put minus 4 in for x, minus 4 times minus 2 is positive 8, and positive 8 is greater than or equal to positive 6. So minus 4 will work. Okay, this solution, or this, if you like, set of numbers will always work in this inequality equation. I'll do one. I'll show you this one here. And there's two ways of doing this. This one is example 3. If I choose 4x minus 9 greater than 3x plus 1. Okay, so x on both sides of the equation. Okay. Same method as if this were a equal sign. I need to collect x's on both sides of the equation. Now it's interesting, now remember I told you you should collect the x's where there are more of them? Remember that? There are more x's on the left hand side, so it's better to collect them on the left hand side. There's a good reason for that, because there's more of them. So shifting the positive 3x to the left hand side, 4x minus 3x is going to leave 1x on the left hand side. I haven't divided all times by a negative, have I? So the sign hasn't changed at all yet. Minus 9, and on the right hand side I've got plus 1. And the last step here would be to add 9 to both sides. Okay, and that cancels the 9 on the left hand side and adds 9 to the right, and I get x equals 10. It's not equal to 10, it is less than, sorry, it is greater than 10. So that's my solution. Interesting that if I'd done it the other way, in other words collected x's on the right hand side, I would have wound up with a negative x plus 1 is equal to minus 9. Okay, all I did here was I subtracted 4x from both sides and got that. If I now subtract 1 from both sides, I wind up with negative 10 equals negative x. Now, to undo the negative 1 in front of the x, I have to divide by a negative. You with me? At the moment, that's not equal sign, that is a greater than sign. However, when I divide by -1, both sides, that changes from a greater than sign to a less than sign. Okay, you notice I swapped the sign because I divided by -1 between here and here. Now you wouldn't necessarily read it this way, this is back to front, you wouldn't read 10 as less than x, you normally read x is greater than 10. If you wind up with an equation like this, you can spin it on its head, but make sure you keep the mouth of the inequality sign open to the same term it was open to. So notice I've switched it again from here to here, but I've kept the mouth open to the x, whereas it was open to the x on this one as well. Now that one is the same as that one. Okay, so two ways of doing it. This way you have to be a little bit more careful with the sign. Okay.